2 days ago on Monday, we already went over conditional probability with Venn diagram and contingency table. Venn diagram and contingency table enable us to visualize the data and hopefully understand conditional probability at early stage. Now, the thing is, what happens if we don't have conditional probability, we don't have Venn diagram and contingency table, and we are just given the probability of some events? And how do we compute that into conditional probability? Now, let's start with an idea. If you take a look from what we did last time, probability of A given B, the way we did that, we first found how many elements in B, right? So let's say we have this Venn diagram here, and then we have set A and set B. This is A, this is B. Now, because the condition is on B, then let's say this is X, this is Y. Then the number of elements in B will be X plus Y. Is it right? The number of elements in B is X plus Y. And on the top is, so this is the condition. We select from, not from the whole Venn diagram, but from the group B, okay? Now, of those in B, how many elements in the intersection, right? How many of those in B also in A? So the numerator was actually the number of elements in the intersection, which is just X. Is it okay? That's what we did last time. Now, we will develop this formula a bit further, such that instead of computing the number of elements, we will change that into probability. Okay, we will change that to probability. Now, what I want to show you is, give me a second. I want to erase the yellow one, but it's kind of so hard to erase. Why? Okay, good. Now, so what we did last time basically was the number of elements in set B, the condition, okay, is on the denominator. And of those in B, how many of them also in A, that's what we put on the numerator. Now, the thing is, if you imagine we divide the top by the number of elements in the whole space, and at the bottom, you also divide by the number of elements in the whole space, then we actually get the probability of A intersect B on the top over probability of B at the bottom. Oh, hold on. Why, Thomas? Why? Let's take a look how we computed probability of B. Suppose I use actual number, okay? Like in the intersection, let's say we have 5, in A only 3, the B only is 7, and then outside you have 10. Okay, so then the total number of elements in this Venn diagram is 25, right? And then the number of elements in set B is 5 plus 7. That's 12, right? That's 12 over 25. So you see the way we compute the probability of B here is the number of elements in B. That's the number of elements in B divided by the number of elements in the Venn diagram. Does it make sense right now? Okay, so what happened was basically, so if I look back, if we look back, then probability of event B, when we did the Venn diagram, we basically did the number of elements in B divided by the number of elements in the Venn diagram. Likewise, probability of selecting element in A and B is the number of elements in the intersection divided by the number of elements in the Venn diagram. Okay, now then, so when we had probability of the condition like this earlier, and we divide the top and the bottom by the number of elements in the Venn diagram, when we put this together, this is what we get. When we put this together, this is what we get. Okay, now of course there are assumptions in between that I have hard time to explain in more details, but for now we can have that feeling that we can use this formula. Now we have that conditional probability formula. Probability of A given B is equal to, on the denominator, instead of number of element in B, we use probability of element in B. Okay, on the numerator, instead of number of element in the intersection, we use probability of event in the intersection. Okay, so if you think about it, it's still the same though. On the bottom, you deal with the condition only. On the numerator, you deal with both. Okay, now the good thing about this then, once we rewrite them instead of the ratio of number of elements, we now write them as the ratio of the probabilities. Then we actually don't need Venn diagram anymore. We don't need contingency table anymore. Okay, let's start. Let's start. Suppose, for example, the simple one, for example, probability of A is 0.6. Probability of B is 0.5. Probability of D intersection is 0.3. Then what is probability of A given B? Now, write down the formula first. Yeah, and I want you to follow me. If you are attending this lecture, then please, if you are attending this discussion, please do it also. Okay, now probability of A given B is, the denominator will be probability of the condition. The numerator is the probability of the intersection. Okay, write down the formula first and then you plug in numbers. Okay, probability of the intersection is 0.3 over probability of the condition B is 0.5. When we compute, that's 0.6. Now, how about probability of B given A? Can you try doing that? Let me give you 1 minute for that. Oh, by the way, the material from this 5.4b will not be in your test one. Let me write it down somewhere. Note. Conditional probability. That's 5.4. Will not be in your test one. Will not be in your test one. But it will be in your test too. Okay, let me write the formula. And what is the notation on the denominator? On the denominator, what will that be?
What was the question, Professor?
Part B here, probability of B given A. What is the notation on the denominator?
P, parentheses, B.
On the denominator, that would be probability of the...
The probability of A?
Yes, that's right. That's the condition. Okay. And then on the numerator, that will be probability of...
B, notion A.
Intersection A.
Intersection.
Okay, but probability of B intersection A is just the same to probability of A intersection B. Basically, B and A happen at the same time. Okay, so that's 0.3 over 0.6. That will be 0.5. Okay, so well, part C, that's a standard question I can ask you. It's what is probability of A union B? This is something you need to know even in your test one. Okay, probability of the union is probability of A plus probability of B minus probability of D intersection. That's 0.6 plus 0.5 minus 0.3. That will be 0.8. Okay, now that's example one. Let me go on to the next example. The next example is slightly harder, but it's simply because that's what it's word problem. Okay, that's word problem. And let me use problems from your quiz, the one you turned in last Saturday. Okay, probability that a legislation pass the House or the Senate is 0.89. Probability that it passes the House is 0.76. Probability that it passes the Senate is, let's say, 0.65. Now, I try to mimic the same question we have in our quiz that you turn in. Let me see. Let me get a better number so that you can relate it to what we have there. 0.62 in the Senate. 0.62 in the Senate. So notation-wise, this is basically probability that it passed the House or Senate is 0.89. Okay, probability that it passed House, not House only, House, regardless passing the Senate or not, is 0.76. Probability of passing Senate is 0.62. Okay, now then, part A, find the probability of passing both. That it passes both the House and the Senate. Now that's one of the questions. That's question part A actually in your quiz, right? So probability of passing either one, at least one, is equals to probability of passing House plus probability of passing Senate minus probability to pass both. And I plug in number. So this is 0.89 equals to, that's 1.38 minus probability of D intersection. Oops. So probability of D intersection is equals to 1.38 minus 0.89. Which is 0.49. Okay, that one is, I think, still easy. Now, the thing is, then if the legislation passed the House, so we know that it already passed the House. What is the probability? What is the probability it also passes the Senate? Now, what you need at this point is your ability to connect the question with the notation that we learned. Okay, what being inquired here is the probability that it passed the Senate, knowing it passes the House. Okay, given that the legislation already passes the House or House of Representatives, what is the probability it passes the Senate also? It's basically like this, right? So in other words, as long as you can translate these word problems into probability notation, then you can use the formula, right? Okay, but write down the formula first. Write the notation and therefore the formula, then you plug in numbers. Okay? And we know from Part A, the probability of the intersection is 0.49. Over probability it passed the house is 0.76. Then we use our calculator. That's 0.644736. Now you try this, part C. If the legislation instead passed the Senate, find the probability it will also pass the House. In other words, knowing that it passed the Senate, what's the probability it passed the House? So the denominator is passing the Senate, right? On the numerator is passing the intersection. Okay. Don't rush to numbers. Don't rush to numbers. So write the notation first. Then probability of the intersection is 0.49 over probability of the passing the Senate is 0.62. That's 0.79032. Any questions so far? One thing I always try when I teach statistics is to try to relate that to our real life. And basically I try not only to relate that to your real life, but also try to teach the one that you can use in your real life, okay, in making decision. So what happened here is the following. Suppose the legislation only passed if it passed both the House and the Senate, right? Then it will go to the president's desk for to be signed into the law. Now, the thing is, if we don't know anything and we just wonder what's the probability pass the House and Senate, then we can compute that. But in between, very likely the bill is being discussed in the House and also discussed in the Senate, right? Okay. Now, when they and basically they discuss that maybe at the same time, okay, and we will see who get passed first. Okay, who will pass that first? Now, suppose if House passed that first, then how likely it will pass the Senate? On the other hand, if it passed the Senate, how likely it will pass the House? Okay, and when it comes to gambling, for example, okay, when it comes to try to see what will happen the next day, then you have this probability to work on. Okay, now, of course, I understand some people, I heard this before. Actually, when we were in class, a student made a comment, Thomas, I hate politics. Can we not talk about this anymore? I said, well, it's okay for me not to talk about this. Okay, but the thing is, like, I'm teaching you the concept. It's not really about House and the politics. No, it's not about the politics. It's now about the probability. Okay, so I can easily change this house and Senate into what happened at home. For example, my son asked for a toy, right? The probability that's okay, with buying the toy is 0.62. Probability that mom's okay is 0.76. Probability either one of them say okay. That's how children, me including, try to make my parents fight. Right when I was really young, I asked my dad, doesn't work, then I went to ask my mom. Right now, suppose we have this situation. Okay, but we know at home, for me to have that toy purchased from me, right? I need to have mom and dad agree. So if I have this probability situation, then who should I go to talk to first? Okay, who should I try to persuade first? Okay, such that at the end, I get both of them okay. Do you want to do the hard work first, or do you want to do the easy work first? Okay. Now, if you want to do the hard work first, then you talk to dad first, because once dad okay with this, then mom, once that's okay to purchase the toy, then mom has 79% probability to be okay also. That's if you want to do the hard work first, you know. But if you want to train your argument skill, like how you will talk to your dad, and you practice with your mom first. Mom, I want to buy this toy. What is that for? That's for to help me to study better. How will that help you study better? It helped me arrange my time, let's say, for example. Okay. How much will that be? So my mom may be on the easy side, right? But at the same time, she also trained me how to talk to my dad later on. Okay, when I talk to my dad, he is a yes or no person. Right, dad, can I buy this toy? No. Please, no. Right, I need this for study. How can that be for study? You call that a toy. Right, so yes, no, not only you, actually. That's we never know where those children, including us when we were still children, knew how to talk into that kind of politics. I mean, they know how to do politics without learning politics formally, right? The politics at home, right? Uh, at home, when it comes to anything to do with money, this is me. Okay, this is me with my children. When it comes to has anything to do with money, I tend to be the one making decision. You know, like a big sum of money. If it is only $10, $15, my wife just like do it herself. Right, but if it is $100, $200, then my wife will talk to me. Now, with my family, with my dad and my mom, my dad had cancer. My dad had cancer when I was still 5, 6 years old. So my mom was basically the one working for us for our living. Okay, so when it comes to money, mom's the one making decision. But when it comes to thinking, is this item is worth purchasing or not, usually that's the one making decision. So dad will think for that first. Okay, we need to buy this. Then after that, we ask mom. So in my family, the role of mom and dad maybe refers compared to other family. But I'm still fine. I'm still fine. Okay, I consider myself fine. I consider myself someone who live quite normally compared to other family. Okay, so it's not an issue. I don't want to say that, well, because my mom kind of be the person who wears the pants at home, which is not true. Even though my mom has control of money because she's the one working, but at home she still listens to my dad, like as my dad's still the head of the house, you know. Okay, somebody needs to have that role. Needs to have that role, and we have that role now. So you see that even though it's not about House and Senate politics, it may be mom and dad, or it is possible that you make proposal, right? If you have, you want to have a startup, right? Like you want to make an app that sells something or trades something, do something, then you need to have your customer, of course, right? And customers always there, try to save their money, and you always have investors, the one who put money into your startup company. So they are the one who wants to make sure that you can make money from the customers. And of course, customers try to make sure that you don't make too much money. Okay, now things is that you have competing argument, you have competing agenda, right? But for you to be successful, then you need to be able to attract customers, at the same time also attract investors, you know. Okay, so which one do you deal with first? Do you need to find customers first, or do you get investors first? Where do you sell your idea first? Okay, now I don't know the answer. I'm not telling you what's the answer, but I'm just trying to tell you that you have two groups of people that you need to satisfy. Okay, then you start working with the probability. That's where the quote unquote your children, I should not say childish, but it's the childlike politics, you know, how to satisfy mom and dad. Okay, mom is the one who care about my growth, but dad also take care of the money, for example, right? If you spend too much money, dad will say something. Okay, but if you don't do anything for your growth, mom will say something. Okay, but if you try to buy something very, very expensive, dad will be screaming. But if you don't spend any money for your education, mom will be screaming. Right? So see, if you have competing requirement, competing agenda, then you start getting into this. Okay. So it's not something rare that we face this in our real life. Now, in reality, we don't have these numbers. In reality, we don't have these numbers. To be more precise, in reality, we don't know how to get these numbers. Usually the numbers available, you just don't know how to get those numbers and get this. It's like from the history, when we see what happened at that time, this Bill A, for example, passed the House but not the Senate. Bill B passed both. Bill C passed the Senate but not the House, and so on and so forth. And then you do proportion, so on. Therefore, the probability. Okay. Now, let me go on a bit further. Part D. This may be on the difficult side, but I hope that by using House and Senate and you can see the situation, hopefully it's a bit easier to understand. Okay, so what we had was the following, that we have passing the House, passing the Senate. And the intersection is 0.49. Okay, passing the Senate 0.62, that's 0.13 probability of passing Senate only. 0.27 probability passing the House only. Now we know that the probability of passing either one of them, basically the union, is 0.89. Right? The total is 0.89. Therefore, probability of not passing either one of them is 0.11. I tried to summarize what we had earlier. So this Venn diagram does not represent the number of elements anymore. It represents the probability of events. Okay, now let's start seeing a harder problem. What is the probability if I want to compute, find the probability of passing the bill or the legislation to pass the House but not the Senate. Basically, what is the probability to pass the House and not Senate? Pass the House and not Senate refers to this one here, right? That's 27%, 0.27. Now, the big question is, how did you get that 0.27, Thomas? If we don't have the Venn diagram, if we only have these informations, if you only have that information, then how would you do that? Let's say you have the intersection. Okay, then how would you do that? Okay, the way we think will be the following. But how? The way we think is the following. We know probability for the bill, for the legislation to pass the House, right? To pass the House is this. Okay, but how the legislation also interact with the Senate? And we see the probability that it passed the House is equal to probability it passed the House and the Senate plus probability it passed the House and not the Senate. Do you see that? Okay, so probability of, so probability of passing the House and not the Senate is equal to probability of passing the House minus probability of passing House and Senate. Now, that's how we look into that. That's how we get that 27%, 0.27. It's from probability to pass the House, which is 0.76 minus probability to pass both. Okay, that will be 0.27. Okay, yeah. But we knew that already, Thomas, is 0.27. Well, how did you know that? From the Venn diagram. Now, how did you do the Venn diagram to start with? Because my issue is what happens if later on you don't have Venn diagram. You see, right? What happens if you don't have Venn diagram? Then you have to build it yourself, right? Okay, you have to build it. But to build Venn diagram may get very, very complicated later on. So instead of building it, building the Venn diagram, I use some understanding now. Okay, let's look back. Probability of passing the House but not the Senate is probability that it passed the House, regardless it passed the Senate or not, minus probability passed the House and the Senate. Because if you think about that, let's say this is the probability of passing the House, right? Now, part of that pass the Senate, part of that not passing the Senate. You see? Now, this is the probability that it passed the House and the Senate. This is the probability that it passed the House, but not the Senate. Okay, so if you want to know the blue one, what you can do is you get the whole probability of passing House minus the probability of passing Senate. That's how you get the probability of passing the House, but not the Senate. Okay, so you get the whole first, the whole House first, and then you take away the probability of passing Senate. Then you're left with the probability of passing House, but not the Senate. Okay. That will be, this will be equals to 0.76 minus 0.49. We know that earlier that's 0.27. Now you try this one. Find the probability that it doesn't pass the House, yet pass the Senate. So the way you imagine, oh, this is the not edge. So together, if I add with this will give me the probability of Senate. Right? If I add them. Okay, so either pass the House or not pass the House. Okay, we get probability to pass the Senate. Okay, now using that idea, then this is probability of passing the Senate minus passing the Senate and the House. Probability of passing the Senate is 0.62 minus 0.49 equals to 0.13. Okay, now let's do a little practice here. Let's do a little practice here. Call this example 3. Call this example 3. Let's say I have probability of E is equal to 0.4. Probability of F is 0.3. Probability of the union, E union F, is 0.6. First, find the probability of D intersection. Second, find the probability of F given E. Probability of E given F. Probability of E but not F. Probability of not E but F. Okay, you try it. I give you 5 minutes to do this. We come back at 4:52. Of course, you need a lot more space than this though, but I fit them into one screen so that you can do 5 problems. Let me move this. Let me move this underneath. Okay, so let's start. What is the probability of E intersection F? Then solution. Probability of the union equals to probability of E plus probability of F minus probability of the intersection. 0.6 equals to 0.4 plus 0.3 minus probability of the intersection. 0.6 equals to 0.7 minus probability of the intersection. So probability of the intersection must be 0.7 minus 0.6. That's 0.1. Then how about probability of F given E? So knowing that if and E already happened or happening, then what is the probability that F also happened? Probability of F given E is equal to probability of the intersection over probability of the condition. That is equals to intersection is 0.1 according to part A. Probability of E is 0.4 according to the given condition. That's 0.25. Let's see part C. Let me do it here. Probability of E given F. That's probability of the intersection over probability of the condition. That is 0.1 over 0.3. That's 0.33333. So how about part D? Probability of E but not F. So what you will do, you take the probability of E first, and then you cut away those for F. Oops. Okay. So that will be probability of E is 0.4 minus the intersection, probability of the intersection 0.1. So probability of E N not F is 0.3. Now part E, how about probability of not E but F? So we take the F first, probability of F, if and F minus probability of the intersection. That's 0.3 minus 0.1, that's 0.2. Now, let's start with this one. How about part F, the probability of E, if and E, knowing not in F. What is the probability of passing House knowing it doesn't pass the Senate? So there's no way for you to do this problem without actually memorizing the formula. Okay, without knowing which formula to use. Okay, I let you use cheat sheet, right? I let you use notes. I even basically you can use anything you want. A student yesterday asked me this question, Thomas, can I print the old tests and use that as my notes? And I say, yes, you can use my old tests and use that as your note, but don't depend so much on that such that you don't need to study. But apparently this is this is a question from someone who actually studied. Yeah, so he said, can I use that though? Because it's just so much, right? And at times I still get confused which formula to use when. Okay, so this person knows that you may have all the formulas, but you don't know which one to use. Okay, now then probability of E given not F. On the denominator, that will be probability of not F. On the numerator, that's probability of E and not F. Probability of E and not F, we already counted earlier, that's 0.3. While probability of not F is 1 minus probability of F. Right? Probability of F, we saw earlier, probability of F is 0.3. So this is 1 minus 0.3, that's 0.3 over 0.7. That is 0.42857.
Professor, how'd you get 0.7?
1 minus 0.3. Yeah, 1 minus 0.3. Right, that's 1.0 minus 0.3.
I was thinking the opposite way, 0.1.
Why 0.1?
That's just how my mind computed it. But when I looked at it, it said a whole number 1.
Yes, yeah, it's probability of not F, right? Probability of not F is 1 minus probability of F.
Understood.
Yeah, okay. Mm-hmm. Now write that down first. I know if you already watched my lecture, then you must have seen a harder problem like the following. Suppose probability of A is 0. Let's say make it 0.8. Probability of B is 0.6. And probability of B given A is 0.5. Make it 0.7. Why not? Make it 0.7. Now, let me ask you questions in this order. Find the probability of D intersection. After you get the probability of D intersection, find the probability of A given B. And then find the probability of the union. Find the probability of A but not B. Maybe not A but B, how about that? And then find the probability of B given not A. Oh man, all of a sudden we jump into all those probabilities. It's just like whatever you see here, you say you don't like word problems, right? So no words here. You know, so no, it's not about word problems though. Trust me, it's not about it is a word problem or not. It's more about your understanding. And the word problems that you have here actually already being summarized in a very, very short sentence in form of notation. Instead of writing, find the probability of A and B, like instead of writing it in sentence, right? You write it in notation. Okay. Now, the type of question you have here tends to be on the harder side. These tend to be on the harder side. But it's not so hard that it's not doable. It's more into that you don't really see this problem in our textbook because our textbook think it's too hard for you. But it's not. No, it's not too hard. It's more into how patient and disciplined you are when dealing with notation. Okay? Now, the thing is, for us to find probability of the intersection before in the past, you need probability of A, probability of B, and probability of the union. Remember that? Right? So before we did this probability of union equals to probability of A plus probability of B minus probability of the intersection. Now, we have probability of A, we have probability of B. This is the one in question, but we don't have this. So you cannot use this formula because for you to use this formula, you need to have 3 items to get the fourth one. You need to have 3 components to get the fourth component. So no, not this formula, not this formula. Uh-oh, Thomas, what should I do? Now, the formula is actually, the method is actually hidden in this notation here. It's hidden there. So in other words, if you know what that means, you may be able to do something, right? Okay. What that formula says is the following. Let me use blue. Probability of B given A is probability of D intersection over probability of A. Is it right? That's what the formula says. Now, the thing is, do we know probability of B given A? Do we know that? Yeah, that's given. That's 0.7, right? Okay, we also know probability of A. So if you know probability of A, probability of the condition, then you must be able to find probability of the intersection. Okay, let's do just that. So that's what the formula looks like. So I write down the formula first. Remember, I told you that many times. Write down the formula first. Write down the formula first. Okay, when it is easy, write down the formula such that when it is harder, you still know how to write down the formula at least. Okay, we never know if the problem is easy or not, though, easy or hard. To be more precise, if you practice enough, then hard problems for other people may become a breeze for you. Okay, now this is 0.7 equals to probability of D intersection over probability of A 0.8. Now multiply both sides by 0.8. That's probability of D intersection. Therefore, probability of A intersection B is 0.7 times 0.8, that's 0.56. Okay, so is this question hard? It is hard for a lot of people. But for those people who knows how to do this, if you ask them, do you think this question is hard? They say, no, it's just like get used to it. Just get used to it. Okay. Now, once you get used to it, then it's something comes from your instinct, actually. Okay. I like to remind a lot of my students, when it comes to doing math, especially in statistics, I encounter a lot of students, they just focus on the final answer only and not paying attention to notation, showing the work properly. Okay. Your intuition is being shaped by doing practice. Okay. What I learned, one of the things I learned when at the beginning of my teaching career is how people learn. So how to teach somebody, I need to know how that person learn. Okay. Now I'm not talking about, well, you know what, Thomas, I'm an audio visual person. You know, I'm a visual person. I'm an audio person. I'm someone who can learn better by asking questions. No, I'm not talking about that. I'm not talking about that. And in fact, you cannot say that. You cannot. It is absurd. It's kind of like nonsense to say that you only learn by audio visual method. Audio visual. Because the learning itself is actually learn how to visualize that. In other words, one of part of learning is that you are given informations where it's not visualizable until you arrange the informations. Okay, you don't have such thing, you don't have that thing. If it's already visualized, then what else need to be done? It's already there, right? Okay, so no, it's I'm not talking about that. I'm not talking about that. How you learn, okay? The way we learn is we learn all those different methods of learning, audiovisual, by asking questions, doing homework, right? Mock tests, group study. That's how we learn. And you need to adjust yourself in every situation, not being a rigid, I'm just this person, I don't want other method. Yet you expect everybody else to be open-minded, right? To say open-minded means to say you need to be open-minded. That implies more than one way. So it's contradictory to say that, Thomas, I'm an open-minded person, yet I only learn one method. What's that? Right? You know, when you say you are open-minded means what? You will learn, you are willing to learn in any modes, okay, any methods. Okay, you want to see other people's point of view. Okay. Now, I want to remind you of a situation that you have before. This is off topics, but I want you to look back into how you learn. Okay, I want you to look back into how you learn. And this is also how I teach my son. Okay, my son is next to me, so I want him to hear that too. Okay, do you remember how you learn multiplication table?
Like by memorizing?
Is that how you learn it?
Well, yeah. When I was back in kinder, like in my home country, we will memorize it. Each week we'll memorize one multiplication by another. And then our teacher will like put us all in a row and then start like asking us what's 1 times 1, 2 times 2, 3 times 3 until
I really want to know which country you're from.
Mexico.
Okay. Now let me tell you this. That's how I learned that too.
See, they're strict. That's when I like. They're strict with us because they make us memorize it.
Do they spank?
If you don't get it right, you have to do the whole thing starting from like the times 2 table.
Oh, but do they spank the students?
No. I didn't get to that.
Well, right now they don't do that anymore in Indonesia, but during my time they spank the student. In fact,
you know what? They would hit us with the ruler like on our hands.
Exactly.
Yeah.
Exactly.
Yeah.
And our hands facing down instead of facing up.
That's fine. But
Now,
we got to memorize them. So
yes. So you see, here's what happened. Here's what happened. When we were at that age, multiplication is something so tough for you and me because we have to memorize that. And it's like, why at that time we say, why do I have to memorize that? We didn't know how useful it was. But at that time, with our mind, we think, why do I have to memorize this? Why do I have to memorize that? Right? Okay. And I didn't say it out because my mom and dad and my teachers are very, very well, in Indonesia, teachers actually spank students, you know. And yeah, so in Indonesia, teachers, we call that guru in Indonesia. So some Indonesian culture, okay. Now, the position of a teacher in the society is higher than parents. It's not like in America. So if you ask me why American education is bad, not only in sense of math, okay, American math is one of the lowest in the world. I'm sorry to tell you this. Like our elementary, middle, and high school math is one of the worst in the world. Our math here is worse than more than half of African country that a lot of people think they are actually poor. But even in their poverty, they still do better math than us. And do you believe or not, Mexican math is better than American one.
I believe it.
Yeah.
So it's to the point that it's if this is the education I get, you know, for my child, I'd rather send him to Mexico. and he will learn extra language on the top of that, right? Learn the math though. plus the Spanish.
It's interesting because when I was brought here as a child, you know, their math here, let's say I was more advanced than they were, because by the time I got here, they were barely, you know, like saying they were barely learning the multiplications while I already knew all of that. I already know how to like divide, sum, multiply.
Yeah. Now the thing
they
is,
were like barely starting it, so it's like, oh, okay, now it just goes low.
Now the thing is, there are so many aspects to talk about this case though, multiplication and how parents and teachers related. In American society, at least in LA, teachers and parents are on the same level. You know, maybe to the point that if parents can have a good relation with the principal, then parents and the principals can work together well, then basically teachers will be more or less being controlled by parents through the principal. That's why I don't teach high school. You know, I hope you know why I don't want to teach high school. Because of that, it's like me as an instructor may be controlled, may be manipulated by parents through principals. No, but that's another side of story. Okay, now let's talk about this multiplication table. You and I, you say that you learn it by memorizing, right? I learned it by memorizing too. And I did say that that's actually the best way to learn it. It is time proven. Okay, it's time proven. Not because I was trained that way, but because I did learn a lot from different cultures, how they teach multiplication table. And the one that students can learn it best is by pushing them to memorize. Okay, now here's the thing though. Then in our society, even in Indonesia, my parents were, especially my dad was actually a math teacher, even though he hardly taught me any math. But one of them is actually multiplication table. So my dad actually insists that we need to learn a multiplication table very early. Okay, my friends did not. I'm not talking about American friends. No, I'm talking about my Indonesian friend when I was still in elementary school. They didn't learn multiplication table. Now, what happened was then this. After 1 year, No, it's actually after a couple of weeks, I memorized that. Then when somebody asks me, what is 5 times 7? I say 35 right away. Okay. Now, then when my friend was asked, when they heard 5 times 7, they didn't memorize that. Okay. Now, notice that all of a sudden, the class gets into two opposite groups. One group who knows multiplication table. And this is the funny thing. Those who know multiplication table wonder why the other group don't know multiplication table. It's 5 times 7 is 35. How could they not knowing that? On the other hand, we have another group. The other group have that question. How could they do that so fast? You see, you end up with two groups who don't understand each other. Okay, a group whose multiplication table is something they memorize by heart. Okay, it's just like strange if you don't know how to do that. And another group who don't know multiplication table, and it is strange if you know it. You see, and this is a fact. This happens. This happens. You can go to elementary school in LA where you have international students from other country. Let's say they come in the 4th grade and the 5th grade. Then this new kid in the block will wonder how the majority of the class don't know multiplication table. And students in this class, the receiving class, wonder how this guy know multiplication table. It's like they don't understand each other. But all of this is because of what? All of that is because of the training. All of that because of practice that they went through. Those who understand multiplication table, memorize multiplication table, already went through a lot of practices. It's not just a lot of practice. I exaggerated with a lot of practices, tons of practice, such that they already forget the struggle. They only have the outcome, memorizing multiplication table. And those who don't memorize, don't go through the multiplication table practice, okay, they never went through what the other side doing. They will never understand how can somebody else doing multiplication table so fast. It's just like 5 times 7. Everybody say 35 without knowing why. I mean, trust me. Okay, I mean, we know why, but that's not how I answer it. It's like when we answer, what is 8 times 6? You say 48, right? Then I ask you, how did you get that 48? When I ask how you get that 48, you start wondering, how did I get that 48? I know it's 48, but how did I get that 48 again? 8 plus 8 plus 8 plus 8. Right? In other words, 8 times 6 is so much into your blood such that you don't even realize. You know it, but that's not how you did it. Okay? You know 8 times 6 is 8 being added 6 times, right? But when you answer 48, it's not because you add them. It's because you memorize them. Okay? So we who already went through that fire of practice, that quote unquote hell of practice, don't understand those people who don't memorize multiplication table. And those who memorize multiplication table don't understand how can people memorize multiplication table so well. Okay, they don't understand each other, but they don't realize that the difference is one group already practiced so much and gets so used to it, and the other group just never go through that practice and never understand how can people just know it by heart. Okay, now this idea of how we learn actually come from the practice of music. One of my niece, I was adopted when I was young, and into a family. And my sister in that family has a daughter who started playing piano when she was 3 years old. Let me show you. Let me show you. This is off topic. I know this is off topic. Like call this my story time. Give me a second. Right. in class, I do have story time, by the way. And I hope when I say story time, it's something you can learn through that story. So let me show you this from youtube.com. Let me see. Where is she? This little kid. This was in 2013. So she was 4 years old at that time. No, 5 years old. She was 4 or 5 years old. Now that lady behind was is my sister, my god sister. Okay.
Wow.
She's good, huh? She's good. She's so 4 years old, can already have that violin, and that violin is the baby of baby violin. Her hands are so small that when I look at that violin, it's just like this. How small is this? Like how big is that? It's basically the paper that we usually use, the 8 by 8.5 by 11.
Okay. Oh, that's small. I have one right here.
Yes, it's like this is half of that. This part here is half of that. So the whole thing here is basically that size of paper. That's how small it was. It's just like, man, that's so small. You know? Okay. Now, and I did play with her. I duet with her. Yes, this is when she was 3 or 4 years old. Yeah, I went to Singapore at that time. Now, my question to you is, do you think she has talent in music?
Dedication and drive.
Repeat again.
Dedication and drive, because only talent can take you so far.
I agree with you. So her mom is actually a music teacher. I actually learned piano because her mom. So when I was in elementary school, her mom, my god sister, in elementary school also, she practiced at home. So I listened to her practice. So I kind of like listen to music too. Her mom may have talent. Okay. We don't know if she has talent. She was just 3 or 4 years old, right? So I asked her mom, why are you willing to spend so much money to send her to music school? And not only one music school, you saw here is 2 music school, violin and piano. Okay, and in Singapore, those are expensive lessons. You know, and why do you want to spend money for that? I mean, if she has talent, then yes, do it. But you don't even know if she has talent yet. And her answer is what struck me. Okay, and I really bring it back to my teaching, my own teaching. She said this, Thomas, we don't know if she has talent or not until we really drawn her into that music, into those practices. Okay, and no, talent is not necessarily something that you have by nature. You need to train that a little bit and a little bit and a little bit, and all of a sudden later on, she can explore that herself. But my job as her parent, especially her mom, is to channel her to that direction. Okay, what you see are she plays piano and violin. By the way, 4 years ago, so when she was like around 10 years old, she was invited by US government to play at Carnegie Hall on July the 4th. She was 10 years old. This is her name. That's another one. Let's see more. Oh, this is last year.
This is not yours, okay?
The Singapore International Music Competition. I want to show you one more. You can see here that she's also play violin, right? Okay, let me stop. You see that she's a beautiful lady, right? Okay, she plays so well. Now, let me pause the recording. There are things that I should not say and record it. Anyway, that's the talk about my niece. I'm still very, very proud of her though. Even though from time to time, I told my sister, hey, you know what? She is still just 10 years old. She's still just 12 years old. You know, you want her to enjoy her childhood, right? Okay, instead of like living an adult life since she was a child. That's not fair, you know. Well, anyway, we already have the probability of the intersection, then how the probability of the condition. Write down the formula first. Do I have to always write down the formula, Thomas? Well, you can try. If you don't write the formula, what happened? You end up writing nothing. So why don't you start writing the formula first, right? So this is 0.56 over probability of B 0.6. That's 0.93333. Probability of A union B is probability of A plus probability of B minus probability of the intersection. We have all the ingredient already at this point. So this is 0.84. How about probability of not A but B? That is probability of in B first, and then you take away the one also in A. Okay, now that will be 0.6 minus 0.56, that's 0.04. Now then, what is the probability of B given not A? That's probability of not A intersect B over probability of not A. That's 0.04 over 1 minus probability of A. That's 0.04 over 0.2. Oh, that's 0.2 also. Okay, now let's do one problem together with your break. One problem together with your break. The following, for example, let's say probability of A is 0.8. Probability of A given B, give me a second. A given B is 0.75. Probability of B given A is 0.5625. Ooh, ugly numbers. I guess I only answered the question first. This one first. What is the probability of A? I'm sorry. What is the probability of A intersection B? And then once you get that one, then find the probability of B. These two questions. Okay, consider that as a puzzle. Okay, you may want to, you will rewrite this first using what the formula will look like, and this one also, and see which formula you are able to use first. Okay, 10 minutes for this plus, no, this one 5 minutes is, no, 10 minutes. So we come back at 6 o'clock. Okay, let's get ready. I don't really see the relationship between what is given here and what we need to answer. So what should I do, Thomas? Well, let's write down the formula first related to this condition and the other condition. Probability of A given B is probability of the intersection over probability of B. While this one here, probability of B given A is probability of the intersection over probability of A. Now the thing is, both conditions already given. So we know these numbers, we also know this number, but we also know probability of A. We don't know probability of B. In other words, we cannot use this formula to answer part A. We cannot use this one. We can use this one though. Okay, that's what I will use. So probability of B given A equals to probability of D intersection over probability of A. Probability of B given A is 0.5625. Probability of the intersection is the probability we look for. And probability of A is 0.8. Therefore, 0.5625 times 0.8 is probability of the intersection, which when we multiply, I think we get probability of the intersection is 0.45. Okay, now that's the probability of the intersection. Any questions so far? Now let's go on. Then how do I use probability? How do I find probability of V? Now you see that from part A, we already get this, which is the same to this one, right? So I can use that probability of intersection together with probability of A given B to find the probability of B, right? So probability of A given B, oops. Probability of A given B is equal to probability of D intersection over probability of B. A given B is 0.75 equals to probability of the intersection 0.45 over probability of B. I will multiply both sides by probability of B. And divide both sides by 0.75. So probability of B will be 0.6. Okay, this part A and part B are the difficult part. But once you get both of these, then you can go on, find the probability of the union, right? But we already have all the ingredients. Probability of A is given, probability of B from part B, minus probability of the intersection from part A. Okay, and then we can answer, for example, what is the probability of A but not B? And what is the probability of not getting B given we have A, right? But these are just the Mickey Mouse part. Okay, the hard part really from A and B. To be more precise, okay? Even though these three questions here are actually easy, I don't even want to do that anymore. You know how to do that already, okay? Even though those three are easy, but you cannot do those three questions if you can't find part A and part B first. Okay, so you can get that easy time in part C, D, E only after you answer hard questions in part A and B. Okay, now I know you and I don't like this kind of question, but this is the type of question you will see, you also see in my test. Okay. Now, let me go on to another subtopic. Another subtopic about independence. We know before that A is independent of B if an A is independent of if and B if the occurrence of event A does not change the probability for event B to happen. Vice versa. Now, that's the definition, right? Now, let's see what's the notation. the probability of event A to happen, okay, does not change. So it will stay the same. If we know B happen or not. So probability of A to happen without knowing what happened to event B is the same to probability of A knowing B happened. Okay. Likewise, probability of B to happen does not change even if you know probability of A happen or not. So to be more precise, if I write it more completely, probability of A is equal to probability of A knowing B happens, which is the same to probability of A knowing B doesn't happen. It's like this. It's like this. It's like this. Will you come to West LA College if you know Thomas is teaching statistics? I'm talking about West LA College. I'm not talking about taking statistics class.
I still have to take statistics, but
yeah, but will you come to West LA College?
Yes.
Well, what if you know that Thomas does not teach statistics? Will you still come to West LA College?
Yes.
So you see the independence there, right?
Yes.
Okay. So the event that you come to West LA College does not have anything to do with the fact Thomas teach statistics there or not. Okay. If Thomas teach statistics there and you don't like Thomas, so they just don't take the statistics class for that semester or take it with another teacher, right? Okay, so nobody can, and that's actually the correct one though. Nobody, it will sound really absurd, so strange, so silly if somebody say, oh, you know what? I don't go to West LA College because Thomas teaching there. It's like, what? What do I have to do with you? Right? Okay.
Yeah.
I mean, you can hate me so much, but still, you still come to West LA College. Yes, it's like, hey, you know what? Does it matter, right? And you will still come to West LA College even if you don't know, if you know Thomas is not there, right? It's like, well, who the hell is Thomas to me, right? Sorry with my hell word, but it is true though. That's really the best way to express independence, right? Now, likewise, the probability of B to happen is the same to probability of B to happen knowing A happened or knowing A not happen. Okay, this is the probability of B to happen knowing A also happens. That's the same to the probability of B to happen knowing A is not happening, which is equals to the probability of B to happen regardless what happened to A. You know, so if Thomas teaching at West LA College, I go to West LA College. If Thomas not teaching at West LA College, I still go to West LA College. So do you need to know Thomas teach at West LA College or not? No, I don't need to because I still go to West LA College. Why? I'm independent of Thomas, right? Okay, now, but these notations, therefore, on the other hand, actually becomes a very, very big asset though. Very, very, very big asset. So suppose we say, for example, probability that when you toss a coin, right? Let's say we toss a coin. We have an experiment of toss a coin and roll a die. The probability that the outcome is head, I didn't say that it's a fair coin, but well, it doesn't have to be fair. The probability that we get head is 0.6. Probability that we roll a prime number, 2, 3, or 5, let's say is 0.2. So for some strange reason, the die is so loaded that it hardly show up prime numbers. Okay, now, my question is, what is the probability that you get a head and knowing that the die comes out prime? Well, hold on, Thomas. Now, the thing is, don't you think these two experiments, tossing a coin and rolling a die, are independent? Yes, exactly. They are independent. So what is the probability of getting head if you know the die give you a prime? Well, that will still be the probability of head anyway. Doesn't matter you get a prime or not. Okay. How about probability you get a head when you toss that coin, knowing when you roll a die, it's not a prime? That's still the same to if you don't need to know if you get a prime or not from the die. That's still 0.6 to have a head. What is the probability of getting prime knowing when you toss that coin is not a head? Well, that's the same to probability getting a prime regardless what you get with your coin, right? It's so independent. So what is then the probability of getting a head and prime at the same time? Then you will see this is probability of getting head multiplied by probability of getting prime. Just multiply them. This is only true if they are independent. This is only true if they are independent. This is 0.6 times 0.2, that's 0.12. Okay, now that's for 5.4b. I don't go over problems from the book anymore because most of them are actually Venn diagram and contingency table one. Some of them have word problems in which I already went over in my lecture. Okay, so I don't think I want to go over that anymore. You can try to do the suggested homework though, okay, from my lecture. Let me go on to 5.5. 5.5 is a long section and difficult, yet important. Now, I will teach only the first part here, the notation. And actually, I would like you to watch, please, please, please watch. Please watch lessons 9 and 10. If you have not done so, please do so during this weekend. Okay, and we will do problems from 5.5 and 5.6 on Monday, which is March the 15th. Okay, now the one I want to teach you right now is how to use calculator for certain notation. There are 3 calculator works I need you to know. I need you to know. I need you knowing. The first one is on factorial. With that exclamation mark. The second one is on permutation. It's NPR. And the third one is combination. It's NCR. Now this N and C and R, the N and R are subscript. They are subscript. Which means it's smaller and lower. Okay, let me show you what happened if I type them. Okay, if I type it, then it will look like this. Let me enlarge this first. Super enlarge that, maybe 24. Okay, NCR, right? Now this is if N and R the same level with C. But no, N and R are not the same level with C. N and R are are subscript. So the N here should be subscript. You see that it's written smaller and lower, not at the same level with that C. The R also smaller and lower. You see what I mean? Okay, so that's what it's supposed to look like. Let me super enlarge that. Okay, in other words, the line where the C sits on cuts through the N, the R. Okay, not like this, not N, C, R, as if N and R are on the same line. No, 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 it's lower. Okay, don't make it so big that it's N, C, R like that, as if that's just same size. No, 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 make it smaller. Okay, our calculator unfortunately write it as if they are on the same line, but that's because they cannot really write it the way we're supposed to write it. Our calculator write it this way. Okay, our calculator write it this way. But when you do handwriting, that's not what's supposed to be. The size for your N and R supposed to be smaller and lower. Okay, now that's one. I believe I did mention about this factorial, permutation, and combination in my lecture video, but I go over that here again to make sure that you really know how to use your calculator. Okay, now, so first one, factorial. N factorial means n times n minus 1 times n minus 2, all the way down to 2 times 1. For example, 4 factorial mean 4 times 3 times 2 times 1. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, if the number is small, you can do it by hand. Like for example, 4 factorial, you can just look at that and say, oh, 4 factorial is 24. But what happens if you have 7 factorial? What happens if, let's say, you have 10 factorial? You don't want to do it by manually, one by one, using calculator, 10 times 9 times 8 times 7, so on and so forth, right? So I will teach you how to use calculator. Okay, and the way you use calculator will be
put the number in and then math.
That's right. So you the number,
math,
and then math,
And then it's like PRP.
PRB.
PRB.
Math.
Number.
PRB exclamation mark. Now, if you already have your TI-84 or TI-83, please follow me with your calculator. If you don't have the handheld one, I hope you have the one you download to your computer. Okay, now let's see. So suppose I want to do 7 factorial. You punch 7 first, and then go to math. Math, do you see this? The third on the first column. The third from the top on the first column on the left-hand side, math, and move your cursor to PRB. That PRB actually stands for probability. Okay, and then you scroll down until you see that exclamation mark, and then you press enter. Okay, so 7 factorial is 5040. 7 factorial is 5040. Actually enter, and then you have enter again. Do I enter twice? Oh, actually only once. I'm sorry. Do you practice? Okay, so 7 factorial, for example, what you punch is 7, and then math, PRB, exclamation mark. And then enter. You will get 5040. Okay, how about 10 factorial? How about 15 factorial? Can you do that for me? You do that. 10 factorial. Hold on, this is recorded, right? 10 factorial. Even if you don't have your calculator yet, at least you know where to find this video, such that once you have your calculator, then you can practice with this. 10 factorial is 3,628,800. 3,628,800. How about 15 factorial? 15 math, PRB, exclamation mark. That's 1.307. Let me copy all of them down. 1.307. 674368. 674368 E12. Oh, what does this mean? What does this mean? This is equal to, basically, because this means 10 to the 12. That's what it means. Okay, so this one here still has 11 digits to the right of that. Okay, basically I will move, let me write it down here first. 1.307674368. To get the integer, you will move this 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that will be 1307674368000. Okay, that's what it means. Now that's for factorial. Permutation. So what I teach you right now is only how to use calculator to compute this factorial, permutation, and combination. What those means, you need to watch my video. Okay, now permutation NPR actually means n factorial over n minus r factorial. So for example, if we have 6 permutes 2, that is 6 factorial over 6 minus 2 factorial. I know it seems to be complicated, but hang in there. If the number is quite small, you may prefer to just do it by hand. Okay, I will show you what actually happened. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So 6 permutes 2 is actually start from 6 and has 2 factors. Okay, the 2 here tells us how many factors to multiply down. So what happened if we have, let's say, 12 permutes 3? It means you start from 12, you have 3 factors, 12 times 11 times 10. Okay, again, this 3 here tells us 3 factors to multiply. Start from 12. Okay, so that will be 132 with extra 0. Okay, now the thing is, what happens if the number gets really large? Let's say 20 permutes 5. Oh, I don't think I want to do it by hand. Then I settle with calculator. Now, how to punch our calculator for this? The calculator work will be, you start with the first number, the 20, first number, and then the NPR, you get the NPR by going to math in the same category with that exclamation mark. Math, PRB, NPR. Okay, and then you key in the second number. And then you get enter. Okay, so for example, I want to compute that 20 permutes 5. So I punch 20 first, 20, and then math, PRB, NPR, and then 5. Okay, let's see what's that. Yeah, that's right. So I think Myra told me that it's 1,800,000 something. Yes, that's what I have. Okay. So yes, the 20 permutes 5 will be 1,860,000 what? 60,480. Okay, let me ask you to try 2 more. How about if I have 17 permutes 8? How about 19 permutes 6? Can you compute that for me? So you do it, I do it too, but I do it with my handheld calculator. Are you done? What is 17 permutes 8? Oh, that's a big number, huh? 980 million. 980 million. 179,200. You don't need to use the comma though, actually. But I just use that comma to help me that I don't miss any number. 19 permute 6 will be 19 permute 6 will be it's actually 19,535,040. That's right. Thank you, Myra. Now, for combination is very similar when it comes to punching it to calculator. Combinations. Okay, that's NCR. So the way you use your calculator will be the same. So the first number, and then you go to math, PRB, NCR, math, PRB, NCR, and then you enter the second number, and then enter. Okay, so for example, 17 combination 8, what will that be? So instead of using NPR, we will use NCR. Okay, 17 math, PRB, NCR, 8. That's 24,310. Okay. 24,310. And so you can just use calculator right away, but I would like to spend a little bit more time to explain how to do it by hand, especially when you have small numbers, especially when the R is small. Now, NCR actually means N factorial over R factorial n minus R factorial. Okay, when the R is small, you will see it's actually it's actually quite easy to compute that by hand. Suppose, for example, I have 7 combination 3. Now, how to compute 7 combination 3 faster than your calculator? Now, do you remember how to do 7 permutation 3? 7 permutation 3, 7 times 6 times 5, right? Start from 7, 3 factors down. That's 7 permutation 3. Now you divide this by 3 factorial. Okay, so that's equals to 35. So we can say this way, n combination R is equals to n permutes R divided by R factorial. Okay, how about 10 combination 2? 10 times 9, right? 10 with 2 factors over 2 times 1. That's 45. Yeah, if the number's small, then it's actually quite easy to compute. Once the R gets larger, then it gets harder to compute. 8 combination 4, for example, that will be 8 times 7 times 6 times 5. Okay, start from 8, 4 factors down, over 4 factorial at the bottom. Okay, then from here, you still can do canceling though. I think that's 70. But the reason I get 70 because I did this. 8 cancels with 4 times 2. Right? 6 cancels 3, give us 2. Right? So 2 times 5 is 10, times 7 is 70. I think if the R is 1 or 2 or 3, then it should be easy to compute mentally. Okay, starting from 4 and on, just use your calculator. Okay, these are the foundations for as the tools that you will use in 5.5. Okay, I give you the very, very basic one right now, but I believe the lecture I gave in my lecture video on YouTube is really, really good already. Okay, I don't need to add more. I want you to watch that. On Monday, we will do 5.5 and 5.6. Okay, this is where I will stop for today's lesson. See you then on Monday. Oh, don't forget. Oh, you know what? I need to go over this. Before I forget. I already post the instruction for your test 1. Some of you may notice that. So if you go to your assignment, you see the instruction for test 1. Okay. Basically, here's what happened. You will go to Zoom at 4:20. Okay. Remember, test days are the days that I require you to attend the class. Okay. So you need to attend this one. You need to take the test. Go to Zoom at 4:20. Why? Because I need to check you in. I need to check your ID and help you with your camera. Okay, now once I check whoever there, then I will send the test file to your Canvas email. Now, once you get that file on your Canvas email, you will work on that. Either you print it out, right? Or you just write into the file. If you don't have printer and you don't write into the file, then you write it on a piece of paper. Okay, you will have 2 hours to work on that test. Okay, we will start at 4:30. Okay, but if you come early and I can check you in early, then I will just send you the file. You have some extra minutes. Okay, but 6:30 you need to stop. Okay, and then scan it to PDF. If you have scanner, do so. If you use Cam Scanner, you use your phone to take the picture and convert that to PDF. Make sure you know how to do that. It doesn't make sense if you then tell me, Thomas, I just don't know how to use my phone for that. It's just like, come on, man. We learned it on the first day, basically the first week of class, right? Okay, now you have approximately 10 to 15 minutes to upload it to Canvas. So you stop working at 6:30, okay? And your submission should be done by 6:45, okay? Now, this means once the clock hits 6:45, the system will not accept your submission anymore. Okay, so if you start, you kind of like stop working at 6:40, you still need to take the pictures, you need to upload it, your internet may be slow. And who knows your internet is slow because you are slow. Okay, you may say they are independent, but I don't know. It seems like it's your internet connection behave the way you behave too, right? Okay, so don't do it last minute though. Okay, 6:45. Once the clock hits 6:45:00, then it will not accept the submission anymore. Okay, so you want to practice during this weekend. You want to practice how to do it fast. Also, you need to practice how to do it right first before you practice to do it fast. Okay, now then some details. What happens if you don't have printer? What happens if you don't have scanner? I explained this on the first day of class, but you really need to have that. Thomas, what happens if I don't have camera? Find somebody with camera, or find your family members with camera at their home, and then you borrow their place to take the test. Okay, you figure out. Okay, but worse in worse, you can borrow somebody else's phone, and then smartphone, I mean, and then you download the app. Okay, Canvas app. You may need to download Zoom also on that app, on that phone, and then you run that as your camera. Okay, I believe in my announcement one, I already explained it well. Announcement one. If you go on down here, there's a video about how the tests will be proctored. Okay, that's for today. Just to remind you of what will happen on Wednesday next week. Okay, see you then.
How early can we be on the Zoom?